Welcome to Rev Reflection. I've got a really cool interview today with my friend Alex, who's an EV mechanic. He'll give you a better introduction of himself. He has a Tesla Model S that has almost 500,000 miles on it, and he is not afraid to dig into EVs. He rebuilds Tesla batteries, drive units. He's just all around a madman. And if you're like me and you don't hate EVs, but you don't really know anything about them, it's really fascinating to hear about how they get repaired. I just wanted to give you a heads up. I had a little bit of a microphone issue at the beginning, so for about the first 10 minutes, my audio's not phenomenal. Otherwise, here you go. I'll let Alex take over.
I own WattWorks, so that's my shop. It's located in Portland, Oregon. I actually used to work for a different shop in the North San Diego area called QC Charge. I was there for about 7 years before I moved up here and started my shop here. And so I've been working on electric cars for quite a while. I've been a bit ahead of the curve compared to a lot of other folks, but there's more and more people getting into this space all the time, and there really needs to be. There's not enough of us to be able to work on all the cars as they age and start coming off warranty, and someone's got to fix them. So
right, exactly. And that is kind of the big thing right now, is that the first year Model S, of course, there was other EVs first. First year was 2012, right? It was first model year.
Yep, 2012 was the first year for Model S.
So we're 13 years old now. So even the cars like yours, which I want to talk about for a second here in a moment, that had the grandiose unlimited mileage 8-year warranty from the beginning, are sort of just on their own now. So it's an interesting topic for sure. And I think, myself included, a lot of car people are afraid just of the concept of working on electric stuff. So yeah, I'm glad someone's blazing that trail. But so speaking of Teslas with high mileage and no warranties, why don't you tell the people what you drive? I'm assuming you still have it, right? I should have asked that before we started.
It's still my daily driver. I've got a 2015 Tesla Model S 70D. So that D is dual motor, all-wheel drive, and then 70 is the smaller battery size. And it's got over 468,000 miles on it now, somewhere in that neighborhood. I'm actually getting ready to take it on a road trip to Utah here next weekend.
Very nice. Yeah, and first question people are going to ask, batteries, drive units, that's Tesla speak for the motors, for those who don't know. I only know that because of you. I'm very much not in tune with EVs or anything surrounding them other than, basic automotive journalism guy kind of understanding of everything. But
yeah, so the original battery pack was replaced under warranty. Again, 8-year unlimited mileage warranty. The previous owner told me that it was replaced at about 260,000 miles. So the current battery pack in it has at least 210, somewhere in that neighborhood. I actually am about 90% certain that it was actually a remanufactured battery when it was put in. So it potentially has even more miles than that, but I don't really know for sure. And then it had the front drive unit replaced, probably around 375,000 miles. And then the rear drive unit is still original.
Wow. That's actually crazy. I forgot about that. So what's your battery degradation like? Well, even assuming that the battery was brand new put in, what are you looking at for total capacity and what kind of range you get out of it?
So right now it's got about 14% degradation. So about 86% capacity compared to what it would have been when it was new. So it definitely has a fair amount of degradation, but not anything super extreme by any means. Actually, the old sort of first generation Model S packs like that kind of tend to hold up really, really well in terms of degradation compared to some of the subsequent iterations of chemistry that came out.
Interesting. And that's just old school, lithium polymer? Is that what they are?
No, they're in NMC chemistry. They probably have quite a bit higher cobalt content than a lot of newer chemistries would have. So that, I suspect, would be probably one of the factors in terms of why they tend to hold up better degradation-wise. It's not quite as high cobalt content as maybe some other battery chemistries, but that would be probably my guess. Like the next gen chemistry would have been like the batteries used in the 75 and 90 kilowatt hour Model S. Those ones tend to have a much steeper degradation curve. Like I would say at this point, most of those cars, even though they're a newer car, most of those are probably about the same amount of capacity remaining as the older 70 and 85 cars. If you compare, kind of like for like,
Gotcha.
even where newer thing, they probably have similar capacity just because they've degraded it.
Interesting. Well, I guess that sort of tees me up for my first question here. It's what are the biggest misconceptions people have about electric drive units and batteries? And I know Tesla is kind of your specialty, right? But I do want to specify that when I met you at first, I was really more excited about the other EVs you had. I think it was actually before you had bought the Model S. It was when you loaned me your Mustang when I was in Escondido, and you still had the electric Ford Ranger twins, as well as it was before the Zen car, correct? You didn't have that either.
Yeah, that would have been quite a long time before the Zen. Yeah. So I've actually, in my time since I've opened my shop here, I've actually branched out quite a bit more, working on other stuff.
Okay.
So I work on a lot of Nissan Leaf, work on a lot of cars that are not super well supported, so kind of what you might call a compliance car. So cars like Fiat 500e, the Chevy Spark, Mitsubishi IMEV, some other stuff like that.
Yeah, okay.
Yeah, and I actually do a bunch of videos about a lot of the repairs that I do for out of spec studios. So they actually have a channel called Out of Spec Renew, which is kind of about keeping electric cars on the road. So I do a bunch of repair videos for that. But yeah, I work on a little bit of everything these days. And I guess probably some of the biggest misconceptions that people might have, I don't know, it's kind of hard to really pin down any one thing necessarily, but I think a lot of people get this impression that like on, various different electric cars, the battery's not going to last more than 100,000 miles. And
Right.
Whatever. But that's really not the case, depending on the car. Some of the compliance cars, maybe that's the case, but anything that's more mainstream, modern, certainly they last in the vast majority of cases way longer.
Right. And that's, I mean, like you said, especially if you look back into the older EV stuff, people who aren't on the West Coast aren't going to run into things like the electric Ford Ranger or the Rev 4s with the Tesla drive units or stuff like that. And it's an interesting thing. Well, I guess the best way to put it is that competition is the best bred thing of innovation, right? So with Tesla making such big leaps and bounds in EVs in the early 2010s, there was undoubtedly a push from other manufacturers to compete. And it's definitely come a long way. But yeah, it's very interesting to see, because I would have thought the same thing. Yeah, cool. Back in the day, a Tesla Model S was starting at 85, 90,000 or something like that.
Yeah, I mean, when they first came out in 2012, most of them were 100,000 plus.
So you're looking at that price tag, and you immediately want to assume that you get what you pay for, sort of equivalency thing, where if you're like, okay, well, if I buy a Nissan Leaf, obviously this thing's going to be garbage in 4 years because it wasn't a $100,000 car, which we later went on to find out were not as well refined as we thought those earlier Teslas. But so that actually does also sort of tee us off for some more questions. But I actually, let's pull back around here. Sorry, we're still getting my footing here for this little chat show I'm putting together. But so we'll talk about a little bit. What when you open up a drive unit or battery, which I feel like is worth specifying here, that you don't just replace parts, you're rebuilding electric components, which sounds terrifying. But what's sort of like a really common failure mode that you see for batteries and drive units, and sort of the process for replacing those, and if there's anything to do to prevent it for somebody that might have an older Tesla or EV otherwise?
Yeah, so just like any car, right? Certain cars are prone to certain types of problems. Whether it's one drive unit, just like one engine might have some issue, or one battery pack in a car might have a certain type of issue. Everything's got its own set of potential problems. When it comes to the earlier Tesla stuff, the biggest kind of Achilles heel on them is on the large drive. So the large drive unit was used in all rear-wheel drive and performance versions, the Model S and Model, actually from the beginning in 2012 all the way up until the first half of 2021. So they continued to use that drive unit for a long time. And its big flaw is that on the rotor, which is the part of the motor that spins, there's a hollow tube that goes through the center of it for cooling. And on the end of the rotor, there's a seal for that cooling system. So we call it a rotor coolant seal. Problem is that seal wears out over time, and then it can actually leak coolant internally inside of it. So that's one of the biggest failure modes that can really destroy these things. The key thing is to catch that problem early before it destroys the motor. If you start to get a bunch of coolant intrusion in there, it causes corrosion, which eventually leads to a loss of high voltage isolation, and it can damage the inverter electronics. You want to avoid that at all costs. There's a pretty simple check you can do. You can pull the encoder sensor out, just visually inspect it to see if there's coolant present, and that tells you the CO is leaking. But as far as the fix for that, assuming you catch it early enough that the drive unit doesn't need to be rebuilt, you can just bypass that portion of the cooling system. They call that a rotor coolant. And actually, when I last visited with you, that was not a thing yet. So that was even a thought that anybody had really come up with doing. But when I was at QC Charge, we developed a manifold to do that, and there's since been a bunch of other different offerings from other folks to retrofit drive units with a rotor coolant elite manifold. And actually even Tesla themselves do that on the latest revision of replacement large drive. So that's revision U is the latest version. And it incorporates their own version of a rotor coolant elite. But they don't actually make the parts available to retrofit an existing. The only way they do it is you've got to replace the whole drive to get that rotor coolant elite.
That is really interesting that it's almost like Tesla was taking cues from those that were working on them themselves. And, well, I guess it wouldn't necessarily be DIY stuff, but people like you. And that it kind of does also beg the question is, what sort of allowances does Tesla have for people outside of their own network repairing their cars?
Things have certainly gotten a lot easier as far as that goes. Like even as little as, say, 3 years ago, it was extremely difficult to get parts from Tesla. I mean, there were some things that you could get, but other things you really couldn't get even if you wanted to. No matter the price, it was unobtainable. But now you can buy most anything, at least as far as full assemblies go. You can buy a complete battery pack, you can buy a drive unit, you can buy any of the high voltage system components. As far as like individual components that are part of those sub-assemblies, some things just aren't available because it's not even something that they would have available as an internal part. So it's not really something that they sell. Like the rotor coolant elite manifold, you can't buy that as a standalone part separate from the drive unit. You can only buy the whole drive. But there are certain things that they do have available. Like another common problem on the battery packs on the older cars is moisture intrusion. And that can occur through the umbrella valves along the side rails of the pack. And you can actually buy those umbrella valves from Tesla. They're pretty much dirt cheap. I think they're like $4 or $5 a piece. So yeah, that's, just another one of those things where in some cases they make it easier than others. And they've opened up the diagnostic software for anybody to be able to use. It's a subscription. So,
whoa.
Yeah. Yeah. And it used to be super expensive actually. But just within the last maybe 6 or 8 months, I think, they reduced the price significantly. It used to be $3,000 a year. Now it's $700 a year. So they cut the price basically down to a quarter of what it was before.
That was actually one of my questions as well, was about software and firmware limitations, because it seemed like the last time I talked to you that we were almost headed towards a situation where in the future, DIY repairs and working on your own car were just going to be off the table entirely. So it is good to hear that it's trending in the opposite direction.
Yeah, they've definitely made leaps and bounds as far as availability for that stuff. And, you know, it varies from one manufacturer to another, right? Some manufacturers make it easier to get diagnostic software than others. I mean, even if you look at some legacy automakers, their OE diagnostic software can be pretty expensive and maybe even essentially unobtainium. Like I think Ford's like OE diagnostic software is something crazy, like an $8,000 or $10,000 a year subscription.
Oh man.
But there's lots of alternative aftermarket options that can get you basically the same functionality at a fraction of the cost. So, there's a little bit of a difference when it comes to some of that stuff.
Yeah, I mean, it's a growing industry as with anything else, right? Like you look at cars from the early 2000s when you first started running into, like, I'm trying to think of the word right now, disables the car from starting. If you immobilizer.
Oh yeah, immobilizer systems. Yeah.
A big one that comes to my mind, being a big Honda guy, is like the 8th gen Civic Si and K Series Acura RSXs, where there's a little bit of an extra step for making them tunable, but eventually K-Tune and a few other companies figured it out. So like, there's always going to be someone that's just charging towards outsmarting the manufacturer, which I love. I love the spirit of that as a concept, of course, but I also like working on my own car. So I think a big thing to address here that a lot of people always want to know is what does it cost? What's a new large drive unit? What's a new battery from Tesla? And what are, we'll say, more affordable alternatives?
So a new large drive unit from Tesla these days is usually going to be about $6,000 for the drive unit itself, plus whatever the cost for installation is. Sometimes at the service center level, sometimes it seems like they kind of subsidize service costs in-house. So like if you bring your car in for certain things that are like really well-known problems, sometimes they actually do kind of a cheaper price than maybe what it would normally be. It's kind of a weird thing. Sometimes it happens, sometimes it doesn't, and you never really know how that's going to shake out.
Interesting.
And then for a battery pack, it depends on the car. So like and the drive units depend on the car too, but for a large drive unit, you're talking about around 6,000. For a battery pack on a Model S, the only new battery pack that you can really get for like an older Legacy S would be what they call a 350 volt 90 kilowatt hour pack. So it's actually not a pack that was ever put in any car from the factory. It's strictly just a replacement only battery.
Interesting.
So it's basically a 100 kilowatt hour pack that they took 2 modules out of and made it just a slightly lower voltage. I think that last I checked, one of those was about 20,000 from Tesla. So pretty expensive. But as far as alternatives go, Tesla does sell remanufactured packs. So they sell their own in-house remanufactured packs. I think that those these days are probably usually about 14 or 15,000. And then there's a big aftermarket, for used packs. And of course, in a lot of cases, old packs can be repaired depending on what the issue is. So, like I was talking before about the moisture intrusion through the umbrella valves in the pack, that's an issue that can render a pack inoperable. And as far as Tesla would be concerned, you need a complete replacement battery. But in most cases, that's actually a repairable issue. Actually, I've got a box of circuit boards here that are usually the culprit of those issues. And if you look at that board there, these 2 capacitors right here, C26 and C27, there's actually sort of a little plastic flap in the pack that rubs the conformal coating off of those. And then if there's enough moisture in the pack where it can condensate, it likes to condensate right there, and it causes corrosion on those capacitors. And then it makes it so that the pack can't measure the voltages on 2 of the bricks. So that's a super, super common failure mode on older Model S packs. That's not too difficult to repair, but it's not something that Tesla will do. So repair for something like this, if you need it, say, usually if one is bad, there's a bunch of others that also are on the verge of failure. So say if your pack needed half a dozen of these, the majority of the cost is going to be the labor to pull the pack apart, open it up, remove the modules, and then inspect all of these. And then you'd replace whatever ones are necessary. And usually that's going to be probably $2,500 to $3,500 to do a repair like that versus, 15 or 20,000 for a replacement pack for Tesla. So
yeah, pretty substantial savings there. And then are you still swapping modules, like replacing just portions of batteries?
So it depends on the situation. So for Tesla packs, module swapping usually does not tend to work very well. That's kind of been mostly hashed out, and it's for the most part become a consensus among most third-party repair shops is that module swapping doesn't hold up long term. Problem is that the battery management system is super sensitive to even the smallest differences in capacity, and not just capacity, but also discharge curve, internal resistance, and a whole bunch of other factors. There's probably at least a half a dozen different factors that play into how well a module will fit within a pack. And even if you find the perfect module, which is like finding a needle in a haystack to find the right module that's going to be the right fit, it might not age at the same rate as the other modules in the pack that were all from the same batch. So in most cases, with a module swap, they usually don't last more than maybe 2 years at best. And in some cases, if you really don't do a very good job of matching it, it might only last a couple of months. So,
oh, wow. Okay.
So usually module swapping is not generally a great plan. And certain failure modes end up with a situation where you end up with cells that have internal shorts. And there's not really a good fix for that. Some people would maybe try to swap the module, but probably not going to hold up well long term. There's a shop in Texas that actually does remanufactured packs where if they have modules that have weak shorts that have issues, you can't really reuse that module unless you could try and go in and isolate cells and stuff. But that's not a very scalable repair method. But what they end up doing is they remanufacture them and they just remove 2 of the modules and make it a smaller size pack.
Oh, okay.
Of course, it doesn't
sort of
work
like Tesla did.
Yeah. It doesn't work if it's already a smaller size pack.
Right.
But you can part the pack out. People love using the modules for, stationary energy storage or electric conversions or, stuff like that. So there's a market demand for the modules. So you can always part out a pack if it ends up being an issue where it's not going to be viable to repair it. And then you can swap in another used pack or rebuilt pack.
Yeah, I actually, I've got a buddy from the rocketry world. We're out camping in the desert. He has a full setup that he runs all this power and everybody's charging their phone, working on stuff, and he uses cells from a Nissan Leaf, I believe. So it's a pretty cool repurpose use, and that's cool to hear that people are doing that with Tesla batteries as well, because that's a thing that a lot of people are concerned about, right? Is when this quote unquote toy car, let me just play devil's advocate for these people, is done, like what happens to the batteries and all these things just going to landfills and stuff. So that is cool to know that there's sort of repurposed generalities for them that'll eventually work themselves out. But and like I said, it's kind of people are afraid to work with high voltage systems and a lot of electricity as well. They probably should be. That's probably a good precautionary outlook to start with. But eventually, as I think the general public gains more understanding of it, we're going to see a lot more stuff like that. And people putting them in e-bikes and stuff like that, and motorcycles. But okay, well, so I'm glad that you've sort of branched away from Tesla specific stuff, because I did want to see if you would give some recommendations for somebody that might be looking for a used EV, but they're not looking to break the bank. So like, if someone is looking for specifically a Tesla, what are like some years to avoid or things to avoid? And if they don't want to purchase a Tesla, which, talking about Tesla right now is a fun sport of avoiding the booby trap tiles into politics. And believe me, coming from the space and rocketry world, I get to run into this twice. But anyway, I'll stop talking now. Just quit digging that hole and let you go off.
Yeah, I mean, there's tons and tons of great options for cars on the market right now. I mean, there's of course you have the Tesla stuff. That's sort of, you could almost call it like a default thing. Like Model 3, Model Y are plentiful and relatively inexpensive cars. There's lots of other great stuff too. Hyundai and Kia have done a really, really good job on their newer stuff that's built on the eGMP platform. So that would be the Ioniq 5, Ioniq 6. I think they're coming out with the Ioniq 9 now, which is a big full-size SUV.
Yeah.
Those are the Hyundai models. And then Kia has the EV6, the EV9. And I think they're coming out now with a compact, the EV4.
Yep.
So yeah, there's a whole bunch of different stuff there. And those cars, they've done a really, really good job on the development of those. They charge really fast. They're pretty reasonably efficient. Last year in September or October, I participated in a cross-country race between a bunch of electric cars. And we actually had the newest version of the Model 3 and the Hyundai Ioniq 6. And those two cars in a 3,000-mile race from Seattle to Boston were 15 minutes apart from each other.
Wow.
Yeah.
That's impressive. I like the Ioniq 6 too. It's a little goofy looking. I like the Ioniq 5 more, but yeah, they're definitely cool cars, and I love that they at least everybody wanted the retro one. I can't remember what it's called. The Envision 74, I think is.
Oh, yeah.
They at least integrated the tail lights, which is more than a lot of concept cars see the light of day. So I'm like, okay, yeah, we appreciate that. Like, we wanted the cool thing, but like, this is good for now. Maybe someday.
Yeah, I actually had the pleasure of, after we did that trip, I drove the Ioniq 6 from Boston back to Colorado. So that was a 2,000-mile trip that I did in that car. And that was actually my first time ever road tripping a car using CCS charging infrastructure. It was great. I mean, the car was fantastic.
That's what I was going to ask about, actually, because it's, the Tesla charging network is pretty well populated, but with alternatives like Electrify America, how's that looking? 'Cause a few years ago, it was like a really big hurdle for anybody that didn't live like on the West Coast or the Northeast to have an electric daily, especially those that can't charge them at home.
Yeah, I mean, the charging infrastructure has really, really come a long way. It's not just in terms of the number of stations out there, but in terms of reliability too. I mean, it used to be that if you wanted to try and take a road trip on, third-party infrastructure, you might not know whether or not the charger is going to work when you show up there.
Right.
But things have really, really come a long ways. Like when we did that trip from that race from Seattle to Boston, nobody had any issues with charging infrastructure. I mean, there might have been a few cases where you'd pull up to a station and maybe one or two stalls weren't working, but there weren't any situations where, the whole location was down or anything like that. It was actually pretty amazing. We were pretty amazed that there were as few issues as there were. And it seems to just be, continuing to improve, and there's more and more stations being put in the ground all the time. And actually, there's some pretty great resources. Like if you're anybody who's ever interested in seeing, I make this road trip a couple times a year. What would it look like if I wanted to buy, this car? What would it take for me to do that trip? There's actually a really cool route planner called A Better Route Planner. And you can put in the car that you want to drive and what your starting state of charge is and where you want to get to, and it'll calculate the best route with the fastest charging or the least charging stops, or whatever parameters you want to put in. It's highly customizable, and it's a pretty cool resource for figuring out how to make that work if it's a concern. And
that's really cool. Yeah, because I mean, that is obviously, I think, still the biggest thing for people is range anxiety. And like, obviously, as EVs, ranges get more and more absurd. It's becoming less of an issue, but also the build out of the infrastructure is helping a lot too. So I don't think we're very far away from it being really not much different from just driving an internal combustion car across the country.
Yeah, for sure. And even, I mean, most EVs have, like in the software, if you put a destination into your navigation, and they'll actually route plan for you and pick charging stops. Some of them are pretty good. Some of them are kind of utter garbage. It really depends on the manufacturer. That's actually one of Hyundai and Kia's weak points for their cars, is the route planning doesn't tend to work super well.
Oh, that's a bummer.
Probably only rivaled by Stellantis. They're about bottom of the barrel for that kind of thing.
Oh boy. Interesting. Yeah, interesting. Okay, well, and speaking of terms of things sort of working out like you're driving an ICE car, look at me, dude. I'm having a nice EV chat. It's from the guy who's still just oil changing and tearing engines apart all the time. But what sort of effect do you think these like super fast charging rates, like the Taycan touts, you can get 100x miles of range in 15 minutes with the fast charging Electrify America stations and stuff like that? How much is really fast charging these packs going to affect the overall lifespan degradation of them?
So most of the information out there, I mean, there's all sorts of people that are studying the effects of all sorts of different factors on pack life. And it seems like, for the most part, fast charging does not seem to have as much of an effect on pack life as most people thought. Now, it kind of depends from car to car, one car to another, how much of an effect it can have. Mostly on cars that have poor thermal management is where it's going to have the biggest issue. So, see Nissan Leaf that has zero thermal management.
Gotcha.
But on cars that have good thermal management for the battery systems, it's really not that big of an issue. I mean, like if we take a look at my Model S, that car was supercharged probably almost every day for 5 years. And
right.
I mean, even if we just look at the current pack, for the first 150, 160,000 miles of that pack's life, it was probably supercharged on a near daily basis. And even now at over 200,000 miles, it's only degraded 14%. So it's less of an issue than I think a lot of people seem to make out. And I mean, the charging speeds and stuff are just ever increasing on stuff. It's getting crazier and crazier. The Taycan is certainly the top of the game here in the US, or at least it was. The Lucid Gravity is now the top of the game. The Taycan was top of the game. Actually, that was one of the cars that was in our race from Seattle to Boston. And it was
really?
Only a little over 2 hours behind the gas car that did the same.
Wow. Okay. Yeah, and that's the thing, is everybody's like, I'm getting old now. I used to just shoot 16-hour drives and take my 2-minute gas stops and just power through it. But I'm like, you know what? Like, for the fact that now 20 minutes worth of fast charging, or say you are in a Taycan, gets you, well, I can't remember the figures. I should have had these pulled up, but we'll say another 150 miles of driving, right? And what's there not to enjoy about like taking a little walk around the gas station for 15, 20 minutes? But I mean, I get it. I really do. If you're still like, no, it needs to be instant, because that's where my mindset was. But some folks are just a little more high strung than others. What are you gonna do? You're never gonna change it. I mean, in reality, half the stuff we could talk about EVs and how great things are getting and how well things are turning out and range. You're never gonna change some people's minds, and that's not what I'm here to try to do. So, people that don't want to hear it have already not listened to this. So, if you're still listening, shout out to you. I want to take a step back for a second to recommendations for EV purchases. Let's say there's people that don't have a super long commute and they're kind of looking at older EVs. I guess specifically, what would be things to avoid? A great example is my friend Matt, who bought an e-Golf from the model year right before the range basically doubled. And he lives in Kansas City, so he's not like in a sort of metro, well built out infrastructure area. He gets to go out to people's houses in the sticks and ask them nicely to use their electricity to charge sometimes when he's out and about. But what would you say are older EVs to avoid?
Older EVs to avoid. Ford Focus Electric comes to the top of the list for me, which I actually own one. That's sort of my like shop get around car, but they're pretty well known for the big issue is they use pouch cells, and the pouch cells in them swell up when they age.
Oh
Yeah.
boy.
The way the cooling system is set up in them is they have all these little coolant manifolds that connect to cooling plates between the cells, and the manifolds are segmented. So when the cells expand, it causes the cooling manifold segments to separate, and then it leaks coolant inside of the battery.
Wow. Okay. That's great.
Yeah, so that tends to cause some problems. My personal focus is actually running with a deleted battery cooling system, so it has no battery cooling anymore. It's basically a leak. But that's a super common problem on the Ford Focus. Once you get to the newer one that had the bigger battery, which is 2017 and up, those have an improved clamping design for the batteries, so they seem to hold up better. But it's still, they seem to be less prone to problems than the earlier ones, but still not immune. That's definitely one of them. Smart Car is pretty well known for having some pretty major issues. They're sort of a not very well supported car. They're really hard to get parts for, and the failure modes that they tend to have can be pretty terminal in a lot of cases, where they'll basically brick the battery. And if they sit for too long with a bricked battery, they literally self-discharge themselves into oblivion. They go into like a junkyard mode, and they just completely trash themselves.
That's interesting that that's built in, though. But it's, not ideal, obviously, but that's kind of interesting to know. I have actually never even thought about that, but it's sort of like, if you have RC cars or something, you can't really just like throw away a LiPo. You want to kill it before you do so. So that's interesting.
Yeah, it's kind of a weird phenomenon that they do, and Mercedes is really the only company that I know of that's ever implemented a bizarre thing. But essentially, if the 12-volt battery gets really, really dead or gets disconnected, and it sits for too long with it disconnected, that's what triggers that series of events. And it'll basically set a permanent code in the BMS that can't be cleared, and then it'll start self-discharging itself. And it doesn't take that long. I mean, it basically just closes all the balancing resistors and just starts bleeding. And usually they'll trash themselves within probably a month or two. There were a lot of smart cars that got destroyed during the pandemic because people didn't drive.
Oh man, I was just about to say, like, if somebody has one but they don't drive it that often, that could be.
Yeah, and a lot of people have them as like a seasonal car where they'll only drive it like during the summer, and then in the winter time it gets parked up, and that that's just another one of those things where it can cause a problem. But yeah, smart car is kind of another one to avoid for reliability reasons.
Good to know.
They're cool cars when they work, but otherwise, reliability wise, they can be a little bit of a nightmare. Other stuff to avoid. I mean, anything is going to have its fair share. Any vehicle can have problems. Everybody knows that. So certain things are just more prone to problems than others, and some are more fixable than others. But the Focus and the Smart are probably near the top of the list for major failure modes. The older Nissan Leaf, the 2011 and 2012 specifically, they have a relatively common failure with the onboard charger. They can sometimes be repaired depending on the failure mode. There's actually a couple different problems that they can have. And those are pretty expensive to replace, the onboard charger, if it ends up being not repairable. Especially for like a third-party shop like me to do it, it becomes to the point where it's basically almost the value of the car.
Gotcha.
And the early Leafs are really, really well known for high levels of degradation too. So unless it's had a pack replacement already at some point in its life, that's usually a big issue with them. I actually just recently bought one of those from a customer who decided to hit it.
Nice.
So now it's mine. It's actually really high mileage for 2011. It's got 163,000 miles.
Wow, that is kind of crazy because the range wasn't spectacular on them in the first place, right? It was like 85 miles or something like that.
The original EPA rated range on the 2011 and 2012 was 73 miles.
Wow, okay. And I know I've seen a couple like for sale in Southern California, they're like, yeah, you get like 14 on a full charge now.
Yeah, especially in hot climates, that's where they suffer the most. This one actually had its battery pack replaced in 2016. So it actually has a newer pack chemistry that holds up a lot better to degradation. They call it a lizard pack. But that pack even probably has 100,000 miles on it. But it's got about 76% capacity on, which is pretty decent for a Leaf with that kind of mileage on it.
Yeah, well, okay, so there's a bunch of them for sale here for like $1,000. What would it cost to put a new pack in one of those?
So to put a pack into one, the first hurdle is finding a good pack. So in where I'm at, packs are plentiful and cheap in good condition because it's a mild climate and the Leaf pack doesn't have good thermal management. So that's the main enemy for the Leaf pack is heat. So hot places, you're going to have less of a chance of finding a really good condition battery. Around here, usually I can find an 80% or better battery for about $2,000 to $2,500. But swapping the battery on the Leaf is actually really easy. I mean, I'm calling it easy because it's easy for me, but you have to get the car up high enough in the air to get the battery out from underneath it. But it's basically only like 8 or 10 bolts that holds the battery in, and it's got on the old ones it's got 2 connectors. On the slightly newer one, it's got 3 connectors. And that's basically it. And then you just have to pair the battery, and that can be done with like a $5 app. So it's not too difficult. If you're swapping a newer battery into an older Leaf, you do have to have a CAN bridge that you wire in so it can translate the communication. But that's another thing that's pretty inexpensive. There's actually there's a guy from Finland. I think he's from Finland. His name's Dala, and he actually open sourced his CAN bridge software for anybody to use. So all you have to do is just buy a CAN bridge. You can buy them on AliExpress for like $5 or $10. Just flash the firmware onto it, and you just wire it into the car, and it works. And you can do that with any size Leaf battery into an older Leaf. You could even swap in a 200 plus mile range battery into a 2011 Leaf.
Wow, interesting. So that's interesting that even that level of being able to like customize and work on stuff is probably a pretty foreign concept to most car people. So I think that segues nicely into repairs and replacements and stuff like that. And what, in terms of like complexity and like general skills required, how does working on an EV, like to the extent that you do, compare to working on an internal combustion car?
So there are certain things that are similar and some things that are different, right? You've got just the regular mechanical aspect, right? You're unbolting components and bolting them back in. That's the same no matter what you're working on.
Wheel bearing's a wheel bearing.
Right. A wheel bearing's a wheel bearing. A control arm's a control arm. That stuff is the same. There's nothing really special about that. But when it comes to, really any modern car, if you're replacing any kind of an electronic component, usually there's some kind of pairing process. So even that is not really a foreign concept for, between an EV and an internal combustion vehicle. As far as anything modern goes, right? You're going to have to, code or pair the component with the car. Some cars are easier than others to do that with, just like everything, right? German cars tend to be a little bit more complicated for that, and other stuff is a little bit easier. So there's some variability there. And then, other differences is there's some tools that are kind of specialized if you're doing anything with the high voltage system. Particularly if it's with the battery pack, with anything that's live, you want to have insulated tools because you don't want to be causing any short circuits or anything. And then there's some other pretty important tools for checking high voltage systems. So like probably a common sort of debilitating fault that you might see with an electric car would be an isolation fault. That's where the high voltage system becomes exposed to the chassis of the vehicle, basically. So, and it can either be an internal isolation fault, which means it's inside of the battery, or it's an external isolation fault, which means it's outside of the battery, which that's kind of the safer one because the battery disconnects itself from the car when it's off. So if it's an external isolation fault, the car's safe, but it won't energize because it has this loss of isolation.
Right.
So that's a pretty common issue that can be shared with lots of different cars, and there's lots of different components that can cause an isolation fault. So diagnosing those kind of issues can be a little bit tricky. Sometimes you have to go, one component to the next, unplugging them and disconnecting them from the system and checking to see, is this the one that's causing the isolation fault, or is it the next thing down the list? And the way that you check that is with basically a fancy multimeter. They call it a mega ohmmeter. And it measures isolation resistance in the mega ohms with high voltage. So it actually tests it at 250 or 500 or 1,000 volts.
Okay. Interesting. Well, I guess in that case, if somebody wanted to start working on EVs, or even like especially doing DIY stuff or like EV swapping other cars, where do you recommend even getting started?
Probably one of the easiest cars to get started to work on would be the Nissan Leaf, mainly because parts are cheap and plentiful, and it's pretty easy to swap components out. The 2011 and 2012, maybe not so much, because some of the parts for those are a little bit more specialized because it was a 2-year only run. They have substantial differences from the 2013 and newer. But once you get to the 2013 and newer Leaf, basically everything is backwards compatible. They've been using the same motor on the Leaf since 2013, and they've done incremental upgrades over time. They put a slightly more powerful traction inverter. You can actually retrofit a more powerful inverter to an older car. That kind of comes with its own issues because you're putting additional stress on the battery and whatever, but that's possible.
Right.
The power delivery module, which is kind of at the top of the stack under the hood, that houses the charger and the DC to DC converter and some other electronics. That's something that can be swapped out if need be. But there's other challenges that can kind of come around that if it has different options than what the car is that you were swapping it from. Like if you're trying to add fast charging to one that didn't have fast charging, there might be some missing wiring harnesses and stuff, and that's a little bit more tricky to deal with.
Right.
And then the battery swaps are backwards compatible. So you can swap a 2025 Nissan Leaf battery into a 2013, and everything just plugs in. All you need is that CAN bridge to make it communicate.
Wow. Okay, that's pretty interesting. I think it's probably worth advising people to do some general research and understanding of what they're up against in terms of high voltage systems and everything like that. Because, I mean, I don't know that I've taken a lot of cars apart, engines, transmissions, all that. It freaks me out, the concept of being like, okay, today we're going to drop this battery pack out of this Nissan Leaf. So it's something that I feel like I wouldn't be inclined to do unless I really was like, I got to understand how all of this is working before I start poking at it with a screwdriver, basically. But
yeah, I mean, there's definitely a safety aspect to working on the high voltage system stuff. But the big caveat to that is that if you're not opening up the battery, there's no high voltage present anywhere. So if the battery's just sitting there, unplugged from the car, whatever, with the disconnect out, even if you stuck your fingers on the 2 terminals on it, there's going to be no power there because it has a set of relays inside of it that open when the car is off. So if the battery's sitting there, even if you had the disconnect in it, there still can't really be voltage there unless both contactors were simultaneously welded closed, which is like, a 1 in a million kind of failure mode. That would be super unlikely. But you can check that.
Well,
you can check that stuff with a multimeter and, see if there's voltage present. And if there's not voltage present, then it should be safe. But obviously, you always want to make sure that whatever you're working on is safe to work on. That's the big key thing there.
Yeah. Well, I mean, that's comforting to hear, at least. I guess the exception to that would be the OG Tesla Roadster battery, right?
Well, even that has contactors in it. So yeah, that's completely isolated from the car when it's off for the most part. It has sort of an internal DC to DC converter that powers the car, so it doesn't have a 12-volt battery to keep things alive. So that is always connected and causes its own issues on the Roadster. That's a totally different sort of subset of stuff.
Interesting, because I remember the first time I met you, there was a Roadster parked outside of the shop, and the battery was in there, and that was the only thing that was like specifically labeled. There's a post-it note on it. It was like, "Don't touch this."
Oh yeah,
Like,
because the
just
battery
a
pack
heads
was
up.
opened up. Yeah,
Oh, okay. Well, that makes a lot more sense.
yeah.
All
You
right,
don't want to go poking your fingers in an opened up battery. That's not a good plan.
yeah, that's
The other
that's
thing I
some
was thinking
good
of
starting
safety-wise
advice.
on high voltage. So the other safety thing with high voltage systems is anything that's part of the high voltage system on an EV is part of what's called a high voltage interlock loop. Generally speaking, sometimes there's exceptions depending on the car. So especially older cars might have some weird implementations for interlock loop stuff. But generally speaking, anything that's part of the high voltage system, it has the connector with the two main high voltage DC pins, and then it'll have two smaller pins in it that either have just a loop of wire that just goes from one pin to the other, or it goes back into the main harness, depending on which side of the connector you're looking at. But basically, it's just one big loop that's interconnected that starts at the BMS, goes through all the components, and then it ends up back at the BMS. And if you interrupt that loop, then the car opens the contactors and removes the high voltage from the entire system. So it's sort of it's a safety interlock circuit, basically.
Interesting. Okay. Well, like I said, that's a little more comforting. I definitely, the curiosity's there, and I'm like, I don't even really have time to work on like my project cars. They're not even in the state that I live in at the moment, but someday I'm like, it'd be kind of entertaining. The itch has been really hitting me with like e-bikes. I'm like, yeah, this is like something I could like start to figure things out on. I have an electric skateboard that the battery is toast because I left it in my garage that gets up to like 120 in the summer, and so it's been discontinued. So my friend, you've met Sean, actually. He was there with me when we toured QC Charge that first time when I dropped the Mustang off. He's the one that gave me the skateboard, and now he's like looking at spot welders and rebuilding a new battery for it and all this fun stuff. But he works for Volvo, so he has experience with high voltage stuff because he's swapping EV90 stuff. But okay. Well, where do you see ultimately like EV maintenance heading in the future? It sounds like things are trending more towards it being open to the world of third-party shops and stuff, and that's good because I kind of assumed the opposite until we started talking today.
Yeah, I mean, there definitely needs to be more shops like mine doing the kind of stuff that we do. But the good thing is that there's more and more all the time. I mean, there's a whole bunch of great shops out there that do really fantastic work and are really working at figuring out how to do different types of repairs on different vehicles. I mean, certain things are kind of closed ecosystems where the manufacturers really try and keep it a closed door system where they don't really want to release repair information and stuff. But people will figure it out. That's basically what it boils down to, is people will figure out how to work on the stuff one way or another. And sometimes it's just a matter of time before somebody figures out how to do, this repair or another. And there's always something new to learn, but the processes are always there to figure out how to get it done.
All right. Well, that's good to hear. Like I said, it really was sort of in my head painting a picture of just everything being closed off to you take it to a dealer or you have a doorstop, basically. So that's good to hear that there's some open air sort of situations going on. But okay, well, before we get out of here, is there anything like any common questions or things you hear about EVs in general that you think would be beneficial for people to hear about from somebody who works on them every single day?
Nothing that I can think of specifically that we didn't really already cover. I mean, I always get questions about longevity and, can you work on this thing or that thing? I do get fairly regularly. I've actually been getting more and more people that are looking at buying an electric car and they want to get pre-purchase inspections done, see what condition the battery is in and all that stuff. So that's something that I've kind of started doing a little bit. And depending on where you're at, there may or may not be somebody that can do that for you. But there's getting to be more and more shops out there. And if it's a concern, it's worth looking around to see if you can find any shops, at least regionally within your area, that maybe aren't too far away, that can kind of be able to work on the cars. Or
Yeah, that's what I was gonna ask was if somebody were to find a car like yours, or even say a relatively high mileage one. I'm starting to see them. Obviously, being in Southern California, I'm gonna run into a ton of used Teslas for sale, but I'm starting to see older Model S's that are now their unlimited mileage warranty is gone, but people took full advantage of it during the use case or the period it was available. So now there's all these Model S's with 180, 190,000 miles for crazy good prices. But also being in Southern California, my opportunity to have them worked on is a lot higher than others. So what, in general, would that be something you recommend against or for people to consider a high mileage Tesla purchase?
I would say if you're looking at something that's higher mileage, the battery is definitely something to keep in the back of your head, that the battery might be nearing the end of its life. Like I would say 250,000 miles, you're kind of pushing end of life for the battery. I mean, there's failures that can occur before that point, and some certainly last longer than that. But like 200 to 250,000 miles, you're kind of getting to the point where you're starting to push the limit of how long the battery might last. So if you're going into buying a car like that, you might want to keep in mind that at some point in the future, you might have to look into replacement battery packs. But, battery packs are replaceable and even upgradable. So you can even upgrade the car to capabilities that it didn't have even when it was new. 100 kilowatt hour pack swaps are getting to be more and more popular on older Teslas, especially the ones that have free unlimited supercharging. A lot of people want to keep the free unlimited supercharging, but they want to put in a newer battery pack that can charge faster and has more range. So there's a little bit of a sort of a cottage industry popping up with people that even kind of specialize in just doing the pack up stuff. And,
Interesting.
I think I've been
Innovation bred every day.
Doing that on my own car if I find a good enough deal on a pack.
That'd be pretty awesome. You basically a plaid swap, right?
Yep, it would be. What I've really been looking for is a 100 kilowatt hour pack, and like in a road trip kind of situation, it would probably cut my charging time at least in half.
Plaid swap is so funny. It reminds me of when you said lithium swap, and I was like, that's like my new favorite modern car term. Lithium swap it. All right. Well, I appreciate you taking the time to be here, man. Do you have website, social media stuff you want to point people to?
I do have my website is just wattworks-ev.com. And as far as the videos and stuff that I do for Out of Spec, you can find that stuff at Out of Spec Renew on YouTube. And there's usually at least one video a week that's, some repair or another that I've had in the shop that I kind of show the process of how I go through repairing it. And I do all sorts of stuff. Plenty of Tesla stuff, Nissan Leaf, Volkswagen e-Golf, Mitsubishi i-MiEV, you name it.
Awesome. Yeah, what I'm really looking forward to is seeing the comments, because in the previous thing that we did together, I don't have any control over it anymore. So if you would like to come back at some point and field some questions or things that people bring up, we'd love to have you.
Yeah, for sure.
All right. Well, thanks again, man. I appreciate it. Thank you, everybody, for tuning in to Rev Reflection, and we'll see you next time.